Hi, today we're talking about section 9.3, stem and leaf plots. In a past lesson, I think it was 9.1, we talked about dot plots, bar graphs, and circle graphs, and how they are great for displaying categorical data. Stem and leaf plots are a graphical representation of data in its frequency and any outliers that may exist. Hopefully you remember what an outlier is, but if you don't, I will quickly review what it meant. But an outlier is a number that is not the typical representation of the data. For example, you are running a race and you're timing yourself to make sure how long it's taking you so that you're preparing for the race. Okay, so you're timing yourself to see how long it takes you to run the 100-meter, and on your third run you accidentally trip and fall. Well, you get up and finish, but that added 5 seconds or something to your time, which may not seem like a lot, but when you look at all the other data that you collected, you see that, oh, it actually is an outlier, and it helps you see that data and see that, well, there was something wrong that happened for that, and that's not going to be the typical piece of data that we would want to analyze. But if there's a lot of data, sometimes it's hard to notice what is the outlier. And so stem and leaf plots are great for helping to identify that. So what are they? What are stem and leaf plots? With stem and leaf plots, you are organizing your data into classes grouped by 10. And each individual piece of data is then divided into a stem and a leaf. So I have this lovely picture here of a stem and a leaf. So the stem is the class of data. That will be a number that's, or a range of values rather. For example, 10 to 19. That's the class of data. The data fell within that range of 10 to 19. The leaves are the individual numbers, represent the individual numbers themselves. The individual number. So, for example, if my list was 241, 243, and 248, and I wanted to put that into a stem and leaf plot, I would first identify my stem. And my stem actually, or how many stems I need. And all of these begin with 24. I want to look at the tens digit and greater. Those greater place values, tens and greater place values, to find my stem. So 24 is the stem, and it's the same for every, so I only need one stem in my stem and leaf plot. Now the leaf, it helps to represent that individual piece of data, so that is going to be the ones place value. There's a 1, a 3, and an 8, so you put that in on the leaf side. And then this, you have to take the stem and concatenate it or join it to each individual leaf to get the individual piece of data. 241. And then join those two together and you get 243, and so on and so forth. So looking at an example, let's say we have our data of this that's in this list right here. And I want to point out this important statement. Positions for leaves can be left empty, but positions for stems must be filled in. So leaves can be empty, stems must be filled in. That may not make a lot of sense, but it will as we go through this example. So first we need to rank the data. We need to put it in order. We have a 2, 6, 12, 25, 27, 29, 42, 50. All right, so we ranked our data. Now we want to separate the data by class. What that means is I'm looking for what the tens digit is, and when the tens digit changes, then I am going to change my class. So separating it by class, I'll just put a red line in between. My tens digit for the 2 and the 6 is 0. There's not a tens digit there. So that belongs to one class. 12 has a tens digit of 1, but the next number up has a tens digit of 2. So 12 goes into a class by itself. Now 25, 27, and 29 all have the same tens digit, 2. So those three numbers go into their own class. 42 has a tens digit of 4. It goes into its own class. And then 50 has a tens digit of 5, and it goes into its own class. Then I go and make my stem and leaf plot. So the stem will simply be the number that is in that tens or greater place values. So there is no number in the tens place for 2 and 6. So my stem is 0. And my leaves become 2 and 6. Then my tens digit for the next class up is 1. And my leaves become 2. The leaf becomes 2. Oh, running out of space. All right. Then my next stem is 2. And my leaves are 5, 7, and 9. The next stem is 4, but we can't forget about the positions for leaves can be left empty, but the positions for stems must be filled in. There would be a gap in between 2 and 4. I have to fill in my stem of 3, even though I don't have any data that represents that. So I have to fill the stem in, but the leaves, there aren't any. There were no data pieces, data elements that had a number in the tens place that was a 3. So I leave the leaves for 3 blank. Then I continue on to 4, and it had a leaf of 2, and then 5 had a leaf of 0. It's pretty straightforward. So if it's confusing you, rewind, listen to it again, but hopefully you understand. So example 9.3a, create a stem and leaf plot using the given data. So we need to rank the data. The smallest digit is 36. Then 40. This is my least favorite part because But everything starts to blur together for me. 36, 42, 43, 45, 50, and 51. That was the... Oh, I'm missing a number. There was supposed to be a 43. Oh, it wasn't 46. Sorry. I'm reading the book for the numbers and saw that I had something wrong on my list. All right, so 43, 45, 50, 51, 53, 51, 53, 56, 58, 75, 58, 75, and then 81 and 84. 81 and 84. And I got 52. All right. I got 50 as well. 50 is already in the list. All right, so separate the data by class. Now we want to look at that tens digit. We don't need to worry about the fact that there's no 2 or no 1. We only need to worry about a stem representing a gap. So the first tens that we come to is 3. So we're going to separate that by class because the next number up moves to a 4. So that all the numbers in the 40s will be in their own class, and then all the numbers in 50s will be in their own class, and then 75 will be in its own class, and 81 and 84 will be in its own class. Then place each data value in a stem and leaf plot. So stem, leaf. So once again, I don't need to fill in a 2 or 1, those stems, because I don't have anything smaller than 36. So I'll start out with my stem of 3. And my leaf will be 6. Then stem 4. And the leaves there are a 2, 3, and 5. So this is the stem I'm looking at now, and the leaves are 2, 3, and 5. Then a stem of 5, and the leaves are 0 for 50, 1 for 51, 3 for 53, 6 for 56, and 8 for 58. Then my next class up is 7, or what's represented my data, but I can't skip. I can't have a hole there in my stem. So I need something, I need that place, that holder in there, that's 6. But I don't have any data that has a 6 in the tens place. So my leaves will be blank. Then I move on to 7, and it has a leaf of 5. And then the next class is 8, and it has the leaves of 1 and 4. So that, and then you separate the stem and the leaf with a line. All right, so that wraps up that example. We have 2 other quick examples to look at. This example is talking about identifying outliers. Remember, the outlier is that number that isn't the typical representation of our data. If you were to look at these numbers represent 10 and 13, and then here we have, I'm sorry, yeah, 10 and 13. And then here we have, no, sorry, whoa, back up. These numbers right here, we're just concatenating these two. So 10 is in it's my 100 and my tens place. This line right here represents 100 and 103. Sorry, I had to get my brain back on track for a second. It went off in la la land. So these numbers right here represent 112, 117, and 118. This number up here represents 84. Well, if you're looking at 112, 117, 100, 127, 84, if you have a whole bunch of numbers listed there for you, it can be hard to maybe see what is the outlier. But when you divide it into this stem and leaf graph, you can see that all of the data really is way down here in between 10, the stems of 10 to 13. And so 84 clearly is an outlier. So that's one way that this kind of graphical representation can help you find that outlier. All right, the final example is example 9.3b. So just as a quick review of just looking at this first line, this 9 in the first one would be 91. 91 shows up in the data list. 91 shows up in the data list again. 93, and then 93 again, then 94, then 96, 97, and 99. So that's just going through that first line of the graph. So how many data values are in the 90s class? You just count the number of leaves. 1, 2, 3, 4, 5, 6, 7, 8. There are 8. This is the 90s class because that 9 actually represents 90. Remember, these classes are classes of 10. What is the mode of the data? So what piece of data occurs the most? We have 4 2s showing up right here. 1, 2, 3, 4. 4 2s are showing up. And I don't see another place where 4 2s are showing up. And they're showing up on the same row of leaves. That's what's important. Because these 4 2s actually represent 112. So our mode of the data is 112. Remember, mode equals the most often appearing number. Most often occurring number. Which stem has the least number of data values? It looks like it's 10. 10 is the stem, and it only has 3, 4, 5, 6, 7 data values, so it's 10. So the 10 stem represents the hundreds class. It would cover the numbers 100 to 109. That's what the 10 stem would actually means, what numbers it would be included in it. Remember, when you're separating by class, you just look for when that 10 digit changes. Are there any outliers for this list of data? Well, no. There's no place that clearly seems to stick out from the rest. So, no. All right. That's it for this lesson. I wish you luck on your homework.